Okay, so good morning, everyone. Is it very good, Akshita? Okay, now when you talk about this chapter, motion, right? I hope all of you remember the concept which we have already covered, okay, right, during essay 1. Now, I would ask you to let me know the topics, the concept that we studied in this. Okay, everyone, one by one, tell me what was the concept when you talk about this chapter. What was the first concept that we studied? Tell me, what was the first concept that we studied? Tell me what.
Distance.
Okay, distance. Okay, so I would say the first concept that we have studied was concept of motion. Concept of motion and and rest. Yes or no? Tell me.
Says relative.
Yes, right, that every motion, when you talk about motion, okay, is relative. When you talk about motion or rest, the concept of motion and rest are relative. Yes or no? Right, are relative. Okay, and it depends on what? Tell me. It depends on observer, right? Or it is also called as frame of reference. Frame of reference, right? Yes or no? Tell me. Yes or no? Okay, clear? Tell me. So yes, so I said that it depends on frame of reference. So your question should be, sir, what is the meaning of that? What is the meaning of frame of reference? Right? Okay. So the meaning of that is, suppose you're looking your friend who is sitting with you, okay, right? If you're looking your friend who is sitting with you, then you can say that you and your friend both are in rest with each other, right? Yes or no? Tell me. Both are in rest, right? But suppose you became Superman and you went to moon, right? And you're observing something, your friend from moon. Then tell me, will you see your friend to be sitting on one place or he will be in motion? Tell me. Motion. Now, suppose instead of moon, if you are sitting on train, okay, and your friend is sitting on the platform, then he will be in rest or motion according to you. According to you, he will be in rest or motion. Motion, right? So I can say the concept of rest and motion is totally dependent on frame of reference, right? Got it? Yes or no? Okay, Yashash, I obviously by train I mean moving train. Okay, right? Okay, so after this the next concept we studied, okay, was position. Position, what is the meaning of position? Okay, so when you talk about space, right, think about it. When you talk about space around us, so the space around us is three-dimensional. Yes or no? Tell me. Yes or no? Right, the space around us is three-dimensional. Agree? Right, so we have x-axis, we have x-axis, we have y-axis, and we have z-axis. Okay, so the position, what is the meaning of position? By position I mean, okay, the coordinates or the, tell me, the distance, the position of anything, any point with respect to these three axes, x, y, z. Yes or no? Tell me. For example, if I say, suppose I'm having a point A, right, whose coordinate is, I hope all of you have studied coordinate geometry, hai na? 2, 3, right? So I'm having only 2, right? So 2, 3 means the x coordinate is 2 unit and y coordinate is 3 unit, right? Yes. So I can say, okay, suppose this is 1 unit, this is 2 units. So x coordinate 2 unit, right? And y coordinate 1 unit, 2 unit, 3 unit, 3 unit. So the point would be, okay, I'll just delete the z axis. Okay, I'll just delete the z axis. Okay, because we will be talking about only x and y axis. So I'll be deleting this z axis. Okay. Okay. So yeah. So the point would be this. So this point is actually point A. Yes or no? Which is 2, 3. Yes or no? Okay. Krishna, we use z-axis same as x and y-axis. Okay. But since our syllabus, which is class 9 syllabus, is basically revolves around two-dimensional motion. Okay, one-dimensional motion or two-dimensional motion, right? We generally talk about only two axes. Okay, so think about it. Now, suppose there are two people. Suppose there are two people, right? Suppose I'm having a person, right? X, or I'm having, suppose Krishna, person K, and he is going from this point to this point. This point is O, origin. So he's going like this, he's going like this, then he is going like this. Okay, right? Got it? Z axis for 3D. Yes, Krishna. Okay. Now tell me, what is the path? What is the path covered by? What is the total length of the path? Okay. What is the total length of the path? Tell me. Covered by Krishna. Tell me. Tell me. 5 units. Very good. 5 units. Easy. Easy, everyone. Because he covered 2 unit in X and 3 unit in Y. Okay. So this path length is called as distance. Distance. Okay. So the total path length 2 and 3.5. Yeah, 2 plus 3 is 5. Okay. Right. So I can say total length of the path. Total length of the path. Length. Okay. I still. Okay. Of the path covered. Path covered is, tell me, is what? Is distance. Yes or no? Tell me, yes or no? Clear? Clear? Anyone have any issue in the definition of distance? Okay. Now, suppose there's some other person, right? Suppose we have Vaishnavi. Okay. Now, Vaishnavi wants to go from O to A, but she takes a shortcut, right? She goes like this, shortest path, right? She took the shortest path. Okay. My voice is cracking, everyone. Is my voice cracking? Is it fine? It's fine. Yes. Okay. So I can say this is the shortest path. Akshata, it is fine. Everyone is saying that it is fine. Okay. Now tell me. Okay. So I can say the shortest path. Shortest path. Okay. Tell me. Right? Between initial and final point. Between initial and final point. Is called what? Tell me. Is called what? Is called, very good, everyone. Very good. It's called displacement. Displacement, right? So here the hypotenuse will be the displacement, right? Make sense? Tell me, make sense? Anyone have any issues? No? Clear? Now, since both distance and displacement are length, right? Since both distance and displacement, right? Is length only, na? Is length. Now where displacement is root 13, na? It is hypotenuse, right? Okay, hypotenuse is root 13. Okay, now these two, both of them is basically length. Then tell me, what should be the unit? What should be the unit? Unit should be unit of length, which is meter, kilometer, centimeter, millimeter, etc. Right? So meter is your standard unit. Meter is your standard unit, SI unit. Clear? Tell me. Easy? Okay. Now, one more thing. Can distance be negative? Tell me. Can distance be negative? Right? No, exactly. The big answer is no. No. Because distance is the total path length. It can never be negative. It is a scalar quantity, right? It is never negative. Okay. Clear? But what about displacement? What about displacement? Tell me. What about displacement? Displacement can be negative. Displacement can be negative. Yes, very good. Very good, everyone. Clear, everyone? Tell me, everyone is clear in this? Anyone have any issue in this? Yes. So I can say, using this concept, I can say, okay, sir, it means distance, okay, distance is always greater than or equal to displacement. Right, everyone? Okay. So this is the concept that we will study in distance. Now, after distance, the next concept that we have to study is something called velocity and speed. So I'll say speed or velocity. It's not or, it's and. Okay. Yes. Yes, Vikas, if displacement is negative, it means it is going in opposite direction. As simple as that. Okay. 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 Now think about it. What is speed? First of all, let's talk about speed. So when you talk about speed, speed can be said that speed is rate of change of distance. Rate of change of distance. Yes, now Navya, displacement negative means opposite direction, as simple as that, right? Okay, because in vectors, negative means opposite direction. Okay, displacement is a vector quantity, okay, and distance is your scalar quantity, right? Yes or no? Clear? Okay, okay, everyone. Now, as I said, speed is rate of change of distance, right? Rate of change of distance. Distance. Okay, which means I can say speed is equal to distance per unit time, per unit time. Now, as I say, okay, if we are talking about distance, the unit of distance is meter, the unit of distance is meter, and the unit of time is second. So the unit of speed is meter per second, right? Meter per second. Okay, clear? Tell me, clear? Right? Okay, now Okay, okay, everyone. Okay, now what about velocity? Tell me, what about velocity? So velocity, we don't have to worry about velocity for now, but what do you think? What would be the basic formula of velocity? Tell me, everyone, what would be the basic formula of velocity? It is rate of change of displacement. Yes? Of displacement. Very good, everyone. Right? Okay, displacement. Okay, clear? Right? So when you talk about basic formula, okay, I'll just write velocity with V is equal to displacement okay by time. So I can say okay, if it is displacement by time, which means the unit is again meter per second, right? So what's the difference between speed and velocity? So speed is scalar quantity, it is total distance, right? Distance by time. And when you talk about velocity, it is vector quantity, displacement by time. So in our syllabus, we will be studying about speed only, mainly speed, right? We won't be studying about velocity. Okay, but I told you for your information. Okay, clear? So I can say, okay, velocity is displacement by time and speed is distance by time, which means, right? If I want to make a graph, think about it. If I want to make a graph, I can say, okay, I'll write like this. Okay, distance is equal to speed into time, right? Yes? Okay, yes or no? Tell me yes or no. Or I can write time is equal to distance by speed. So actually there is only one formula. We can just transpose and cross multiply to get different formulas. Now, if I'm talking about this formula, think about it. This formula, distance is equal to speed into time. So I'll write distance as suppose x, this is speed as v, and this is as t, right? Okay. Now suppose I want to draw a graph of x and t. Think about it. If I want to draw a graph of x and t, I hope all of you know how to draw a graph. Yes or no? Tell me. Yes or no? Right? Yes. I'm hoping that everyone know how to draw a graph. Okay. So this is your x-axis. I'm saying time on x-axis and this displacement on y-axis. Okay. Now, if my graph is like this, okay, if my graph is like this, what is the meaning of this graph? Tell me, what is the meaning of graph? Tell me, what is the meaning of this graph? Is this here the origin, right? Is this distance? Yes or no, right? It is starting from this point, right? It is starting from point x naught. Okay, clear? Yes. And what is this graph? It says it is starting from this origin. Now, here origin is basically, tell me, relative. Yes or no? Tell me, yes or yes. Yes, Yashila. Initial velocity is not zero. Okay. Now think about it. Think about it. When you talk about these two, okay, suppose the velocity of this is v1 and the velocity of this is v2. What can you say about v1 and v2? What can you say about v1 and v2? Are they same or are they different? They are same, right? They are same. They're not different. Why? Think about it. When you talk about velocity, so velocity is equal to x by t. And x by t, which is this. Think about it. X by t is what? X by t is this is x, this is t. Okay. Now tell me, these two are parallel, yes or no? These two are parallel. These two lines seems parallel, yes or no? Tell me, yes or no? Tell me everyone, this seems parallel, yes or no? If they are parallel, so if this angle is theta, what about this angle? This angle is also theta, yes? Tell me, yes? Yashash, you don't understand the concept now. Tell me, is this length denoting your velocity, or is this ratio which is denoting the velocity? Tell me, is this length represents velocity, or is the ratio which represents velocity? Ratio, Prahlad, ratio na, velocity is x by t. X by t, it's the ratio, right? And this ratio is called a slope. Slope. Okay, that is what we have studied, right? Slope of xt curve, slope of xt curve, right? Okay, xt curve, right, means xt graph represents velocity. Got it? Tell me, got it? Yes or no? Right? Okay, now tell me, in this, if you talk about this, it's a straight line. So what is the basic definition of straight line? Can I say if it's a straight line, which means slope is same throughout the length? Yes or no? Right? If I'm saying that it's a straight line, so for straight line, right? Okay, I'm not audible, guys. Am I audible to everyone? Tell me, am I audible to everyone? Yes, I'm audible to everyone. Okay, Yashash? Okay, so for straight line, what do you think? The slope is same, or slope changes? Tell me. For this straight line, slope is constant, yes or no? Tell me, yes or no? Tell me, yes. Slope is constant, same. Clear? Yes, I'm speaking. Everyone can hear me. Okay. Right? Okay. Now, so I can say if the xt curve is straight line, right? Then the motion is uniform or non-uniform? Tell me. Then the motion is uniform or non-uniform? Tell me. Motion is uniform. Uniform as velocity or as speed do not change. Slash speed here, for you it's speed, okay, is constant, is constant, right? Okay. Prahlad, that is why you have half concept. You remember only half of this stuff, right? Tell me, slope of which curve? Here it is xt curve. If I'm talking about xt curve, then slope of xt curve will give you velocity, yes or no? Right? Slope of xt curve give velocity. Okay, right? Now the next term is acceleration, right? The next is acceleration. What is acceleration? Prahlad, your concept would be clear now. Okay. Now the acceleration is rate of change of what? Tell me. Rate of change of velocity. Yes or no? Right? For you, it is speed. Okay, but it is actually rate of change of velocity. Clear? Right? Yes. So I can say, okay, acceleration is change in velocity by change in time. Agree? Tell me, agree? Right? Yes, or you can just write, okay, change in velocity, right? V by change in time. Okay, means suppose I'm saying, okay, a person is going from this point to this point, from point A to point B. Now at point A, the velocity is v1. At point B, the velocity of v2, and the time taken is t seconds. T seconds. So what would be the acceleration? Tell me. Then I can say, okay, acceleration is now change. Change is always final minus initial. Change is always final minus initial, right? Final velocity, final v minus initial v by time taken, time. So it is v2 minus v1 by t. Acceleration is equal to, clear everyone? Tell me, clear? Right? Yes or no? So generally we write v2 as v, and generally we write v1 as u. So it is v minus u by t. So this is the basic formula. Yes? Okay. Now when you talk about the graph, so I can say, right, v minus v is basically what? Change in v. So delta v is equal to a into t. Yes or no? Yes or no? Change in velocity is a into t. Here delta, right, represents change. Delta represents change. Okay, everyone, tell me. Okay, clear? Okay, now let's draw a curve. Okay, let's draw your curve. Think about it. So in this is time, and this is, tell me, v, velocity. Okay, this is velocity. So this is velocity time curve. Got it, Prahalad? This is velocity time curve, right? Velocity time curve, time graph. Okay, now here, if the initial velocity, suppose this is initial velocity u, okay, and it is going like this. If it is going like this, then this slope represents acceleration. Yes or no? Tell me, yes or no? So acceleration is this slope at any point, acceleration at any point. If you are talking about this point or this point, this point, it is delta v by t. Clear, everyone? So I can say slope of vt curve represents acceleration. Right, anyone? Right, everyone? Everyone got this concept? Everyone got the concept clear till this point? Tell me, yes or no? Speed time, this is speed time graph only. Vastav, velocity time is speed time, right? According to your syllabus, it is speed time curve. Okay, right? Okay, because you should use speed only. You should not use velocity. Okay, right? So distance time graph represents speed. Distance time curve represents speed. Displacement time curve represents velocity. Okay, and speed time curve, right? Speed time graph. Okay, Mansa, see na, this is basic formula, right, Mansa? See, v is equal to x by t. So if x is distance, it is speed. If x is displacement, it is velocity. As simple as that. But according to your syllabus, according to class 9 syllabus, we just have to study about speed. Okay, so they won't tell you displacement, they'll just tell you distance. Okay, clear? Right? Okay, easy. Mansa, got your concept? Anyone have any other doubt? Tell me, anyone have any other doubt till this point? Anyone have any other doubt till this? We studied basics of distance, displacement, speed, right? No? Yes, yes, Chandan, right? Definition of acceleration, you should write this. If you write this much, you will get full marks. Okay, so let's talk about graphs. Okay, now I hope all of you remember, right, these concepts. Now tell me, how we have studied only two graphs, yes or no, right? One is your position time graph or distance time graph. Position time, okay, and second is speed time. Yes or no, tell me, right? Step by step. Okay, because slope of distance time represents speed, that's what we are discussing, right? Okay, right, position time is basically your distance time. Okay, distance time, this is same. Okay, now let's see this. Let's see. So I represent one graph like this. Okay, and the other graph like this. See the difference. Okay, see the difference, right? Now this is x and t. Now this x can be written as d also, right? This is distance time graph. Yes or no? Tell me yes or no. Clear? Okay. Okay. And this is speed time graph. Clear, everyone? So this is what you have to see, right? Okay. My voice is cracking. Everyone, my voice is cracking. Can you hear me, everyone?
Yes, sir.
Everyone can hear me, right? Yes. Okay, everyone can hear me. Okay, I'm audible. Okay. So what we have seen, let's see, right? So we have seen a graph like this. Okay, we have seen a graph like this. Okay, so this graph represents constant velocity, right? This represents constant velocity, constant speed, right? Sorry, speed, constant speed. Yes or no? Yes or no? Right? Or I can say uniform motion. Uniform motion. If the distance time curve is a straight line, which means constant speed and it is uniform motion. Clear, everyone? Tell me, clear? But if I talk about a motion like this, right? Like this. Okay. So can you say, is this a constant velocity? Tell me, is this a constant velocity? No, right? Because the slope is changing. It is not a straight line. So this is your non-uniform motion. Clear, everyone? Tell me, clear? Okay. Okay. Very good. Now, when you talk about this VT curve, okay, when you talk about this VT curve, so let's draw VT curve like this. Okay, let's draw VT curve like this. So I can say the slope, take any 2 points. I'll take this point and this point. Okay, let's take these 2 points, this point and this point, right? So I can say this is U and suppose this is V. Okay, so I can say this x-axis is what? This is time taken, yes or no? Tell me. This x, change in x is time taken. Yes. Line parallel to time axis represents what? See, it depends which graph you're talking about, right? We will see, Prahlad. Okay, so here, right, the slope, I'll say this is the change in speed, which is v, total distance v, and this distance u. So this is v minus u, and this is time. So here, v minus u by time represent acceleration. Yes or no? Tell me yes or no. Right? Okay. Why they should be under root? Why they should be under root? Okay. See, in your syllabus, we generally make one-dimensional motion. Okay, we generally take one-dimensional motion, which means speed and velocity are same according to your syllabus. Okay, according to your syllabus, right? Speed and velocity is same. Okay, but when you talk about higher grades, okay, it is constant velocity. It is actually constant velocity. Okay, for uniform motion. See, the slope is perpendicular by base. Slope is defined by what? Perpendicular by base. Okay, that is your slope. I'm not finding this hypotenuse, right? Okay, got it. Prahlad, obviously we are not finding h base. That's it. That's what slope is. Clear? Got it? Okay. Now, the class will be till 12:30. Okay, the class will be till 12:30 because you won't understand more than that, right? Because the whole session is just teaching session, right? Okay. So let's see one more graph. Okay, everyone tell me what this graph represents. Okay, what this curve represents. Right? So this is x, this is t, and I'm making a straight line like this. So what does this represent? Tell me, what does this represent? Which type of motion? Very good, Prahlad, very good, very good. So this represents rest, right? Object is in rest. Object, right, is in rest. Yes, very good. Janvi, it is object in rest now because x, right, is not changing. X is not changing. Okay. So if it is rest, which means velocity is equal to 0. Yes or no? Tell me. Yes or no? Speed is equal to 0, right? Speed is equal to 0, right? If x is distance, then speed. Okay. Right? If x is displacement, then it is velocity. Now, if the graph is like this, if this is like this, okay, think about it. And I'm talking about this. Okay, and this is speed time curve. Speed time curve. Then tell me, what is the meaning of this? What's the meaning of this? Constant speed, right? Yes or no? Constant speed, right? If it is speed, okay, clear, right? Here acceleration is 0. Acceleration is 0. Clear? And this is your uniform motion. Right? Anyone have any issue in this? Tell me. Anyone have any issue with this? Tell me, guys. No? Clear? Yes, yes, Shakib. Okay. That is the meaning, because think about it. Now, don't remember, think, right? Do not remember any concept. Try to think and visualize. Okay. Okay. See, the meaning of this is, as the time passes, velocity is not changing or speed is not changing. Speed is not changing, which means there's no change in speed, right? No change in speed, right? So acceleration will be 0 and speed is constant. Okay. Okay. Clear? Right? And if it's not a straight line, then it is your non-uniform speed. Clear? Okay. Okay, everyone. Very good, everyone. Okay. The next concept was, right, equation of motion. Equation of motion. Okay, right? So we will start with first equation of motion. We will derive all the equation of motion. Okay, right? So first of all, what are the assumptions, right? First, we will think what are the assumptions, what is the condition? Kinematics means motion, right? Study of object in motion is called kinematics, as simple as that, right? So the condition is acceleration should be constant, right? Acceleration is constant. Okay, means acceleration is not changing, right? And generally, no, equation of motion can be written in 2 dimension also, but we study in 1 dimension only. Okay, so this is the only condition that we will see. Okay, right? Acceleration is constant. Got it? Now, so let's talk about first equation. So first equation is very easy. We all studied first equation. First equation is from derivation itself. Okay, so I'll tell you the derivation of first equation also. Okay, now when you talk about first equation, it is basically this. When you talk about distance time graph, right, or velocity time graph, let's take about velocity time graph. Suppose this is your initial velocity u, and this is a final velocity v at this time, at time t. Okay, so I can say this slope, think about it, this slope is basically this length, which is v minus u, and this length, which is t, right? This is t. So I can say, according to the basic definition of acceleration, acceleration is defined as slope, which is perpendicular by base. Clear? Yes or no? This is the derivation of first equation. Now, if you rearrange it, so I'll say, okay, at is equal to v minus u, and I want to find v if u is given. So v is equal to u plus at. Yes or no? So this is your first equation of motion. Clear? Tell me, clear, everyone? Yes, aware, while deriving, you should write condition also. Okay, right? Because if it's not a straight line, you cannot write it. Okay, clear? Clear on this? Now, this is easy. Okay. Now, let's think about it. Second equation. So write down the second equation first. Okay, when you talk about second equation, I can say second equation is what? S is equal to ut plus half at squared. Okay, how to derive the second equation, right? How to derive the second equation? That is my problem. Now we know that. Think about it. Let's draw xt curve. Okay. Let's draw your distance time graph. Think about it. Everyone think about it. This is your distance time graph. This is your distance, right? X, and this is time, right? Okay. Now tell me how to draw this. How to draw this? Yes, very good. I can say when you talk about distance time graph, okay, distance time graph, the area under the graph, right? I'll just take this line like this. Okay. So I want to find the distance, right? Initially, I'll take from this point. Right? This point to this point, till this point to this point. Okay, I want to find the distance covered in these two time intervals. Yes or no? Tell me, yes or no? Or I'll just take from the origin only. Don't worry. I'll take from here only. From here to here, I want to calculate the distance covered, right? But you says that if it is xt curve, then distance curve should be this only, right? Yes or no? If it is xt curve, then distance curve should be this only. So obviously this should not be x. Yes or no? Tell me, yes or no? Right? Yes, this should be velocity. This should be velocity. Agree. Tell me, agree. Right? Curve. Okay. Right? Mansa. Okay. First of all, when you talk about this, think about it. Think about it. Okay. Think about it. S is equal to what? S is equal to, okay, or I'll just write like this. Distance is equal to speed into time. Speed into time. Yes or no? Yes or no? Yes. So just take this example. Just take this example. Okay. Just take this example. Everyone think about this example. Suppose I'm having a graph like this. Suppose I'm having a graph like this. Okay. Now this is 0 and this is time t. Okay. This is time t. Now tell me, this velocity is v, this speed is v. Agree. Think about it. Right? Yes. Now, what do you think? What is the distance? Tell me here. If distance is equal to speed into time, speed is this unit. Speed is this length. Yes or no? Speed is this length. Agree. Tell me yes or no. Speed is this length and time is this length. So what can you say? Tell me what is this length into this length? What is length into breadth? Tell me what is length into breadth? Tell me area. Yes or no? Make sense or not? So I can say, okay, distance is, right? Distance is nothing but area of speed time graph or area under speed time curve. Right? Yes or no? Tell me. Yes or no? All of you got this concept? Now here it was straight line. That's why it is this. But it should be true for anything. No? It should be true for any graph, right? It should be true for any graph. Agree? Yes or no? It should be true for any graph. Right? Okay. Any VT graph, I'm saying Prahlad, right? Any VT graph means it should be true for constant acceleration also. Okay, that's what I mean, right? Obviously, I'm talking about VT curve only. So let's take this curve, right? Okay, so let's take this curve, second curve. Okay, let's take this second curve like this. So according to this definition, I can say, okay, sir, the area under this, right, this is u. Okay, I'll take this point. Okay, and I'll say that area under this will represent the area. Think about it. This area, okay, this whole area represents what? Tell me. This whole area represents, tell me everyone.
Distance.
Distance. Very good. Okay. So can I say this? Can I say this, that this whole area represents distance? Okay, and how to find this area? Tell me how to find this area.
Area of the trapezium.
Area of trapezium, yes or no? Now we know that this is V, this is U, and this distance, this is V, this is V, right? This is your speed and this is time. Clear everyone? Tell me, everyone is clear till this? Everyone is clear till this? Okay, so I can say distance is equal to speed of trapezium, sorry, area of trapezium. Area of trapezium. Clear? Which is half into, tell me, what is the area of trapezium? Half into sum of parallel sides
Into height.
into height. Anyone have any issue in this? Anyone have any issue in this? No? This is the basic formula na, of trapezium, area of trapezium. So let's write it. Let's write it, everyone. Let's write it. Okay. So it is half into sum of parallel sides. So parallel sides is U and V. So it is U plus V, U plus V. Okay, right? U plus V. Okay. For this graph, it is trapezium, na Prahlad? We talk about constant acceleration. That is our condition. I hope you remember the condition. The condition is this, that acceleration is constant, right? Okay. So either it will be this or it will be this. Only these two graphs we have to study into time, But here we don't know V, right? Okay, because we just know acceleration, this U, A and T. I want to find, okay, in terms of U, A and T. So I can say, okay, I'll use the first equation. I'll use V is equal to U plus AT, right? Yes or no? I'll use V is equal to U plus AT in this. So let's see what we will get. So half bracket U plus, instead of V, we will use U plus AT into T. Anyone have any issue in this? Tell me, anyone have any issue in this? Or is it clear?
Clear, sir.
Clear, right? Very good. So can I say, okay, it is half 2U plus 8T into T, which will give me UT plus half 80 squared. Okay, this is the formula. This is the formula. Chandan, what is the height of this trapezium? When you talk about this trapezium, what is the height? Height is this, na? Height is distance between two parallel sides. This is T, right? Got it, Chandan? Clear? Anyone have any issue in this? Anyone have any issue in this? Now this is asked a lot. This derivation is asked a lot. Okay, people ask this derivation in your exams. This derivation will be asked. Okay, right? This derivation will be asked. So I can say, right? Let's summarize. When you talk about first equation, right? Third equation will solve, right? First equation will derive. Now first equation. When you have to use first equation, when what is given? U is given, right? A is given and T is given, and you have to find velocity. You have to find V. Okay, then you have to use first equation, which is V is equal to U plus AT. Okay, second equation. When you have to use second equation, tell me. When you have to use second equation, when U is given, A is given, T is given, right? But you have to find what? Find, tell me, S, distance, right? Then it is S is equal to UT plus half AT square. Okay, right? Now third equation. Okay, sir, you said if V, U, AT is given, U, AT is given, but what if T is not given? What if T is not given, right? So third equation, right? Let's think about that. Suppose instead of giving t, they have given me u, they have given me a, and instead of t, they have given me s, right? They have given me s. Okay, they didn't give t, they gave me s. Now question is how to find v. Find v. Okay, the question is find v. Find v. Okay. Now you will say, sir, easy, no issues, right? No issues. Okay. So I can say, I can use these two equations, yes or no? I can use these two equations, right? If t is not given, I can write, okay, sir, no issues. If t is not given from first equation, I can say t is equal to, think about it, v minus u by a, yes or no? Yes or no? From first equation. From first equation. Anyone have any issue in this? Tell me, anyone have any issue in this? No? And I can put this t, put t in second equation. Yes or no? Tell me, agree? Agree everyone? Can we do this? This? Yes? This is the derivation that will be asked. Okay, very good. Very good everyone. See how smart you guys are? Okay, now if I'll do that, write it down. S is equal to ut plus half at squared. I'll put this value. So let's put this value, everyone. Let's put this value. Okay, everyone should put it with me. Okay, so u bracket t. I'll write t as v minus u by a. Okay, plus half a t square, which is v minus u by a whole square. Anyone have any issue in this? Tell me, anyone have any issue in this? Now here you have to work, right? You have to work something. You have to basically solve it. I hope all of you know how to solve equations. So let's solve. So it will be what? V into u, uv minus v into, so u into u square divided by a, step by step. Everyone, please solve it step by step. Okay, plus half. Now a by a square, because it will be square now, will become a only, right? So we will get a only because a and a will get cancelled, right? A by a square, right, is a only. Now it is v square, v minus u square is v square plus u square minus 2 us, sorry, 2 uv. Yes or no? Minus 2 uv. Anyone have any issue in this? Tell me, anyone have any issue in this? Clear? Right? Now, take the LCM. So I can say the LCM of A and 2A is 2A. The LCM of A and 2A is 2A. Yes or no? Now, this should be multiplied by 2. This should be multiplied by 2. So it will be 2 uv minus 2 u square. Okay. Plus, rewrite everything. V square plus u square minus 2 uv. Now, if you see this, plus 2 uv minus 2 uv will get cancelled. Okay, u square minus 2 u square. Okay, will give you what? V square minus u square by 2a. S is equal to. This is what you will get. Okay, clear? Clear, everyone? Now, if you cross multiply, okay, Bhavani, they'll ask, right? They'll ask which method you have to use, right? You can use this. I'll tell the graphical method also. Okay, so it will be v square is equal to u squared plus 2as, right? That is the formula. Okay, clear? Now, first and second is graphical method only, na? First and second is graphical method only. Yes or no? Right? Third, we use this directly. Yes or no? Clear, everyone? Clear with this? Yashash, that would be your homework, right? Okay, find other way and send me. Okay, totally other way. It's not just steps, totally other way. Different method, completely different method, not just steps. Okay. And you should not spend more than 15 minutes. ऐसे नहीं एक बार दिन भर लगा दिए बोले विष्णु सर ने बोला था. You should not spend more than 15 minutes and it should not have any other concept. Basic ये नहीं कि differentiation integration वाला खोज के ला रहे हो, वो नहीं. Same 9th के concept पे, right? 9th के concept पे. Okay? You should not use integration differentiation at all because obviously there's a different method which use integration and differentiation, right? But it is not in your syllabus. We will study that in class 11th. So you should not do that. Okay. Clear, everyone? Tell me, clear? Anyone have any issue in this? Okay. Right. Now let's identify some graphs. Let's identify some graphs. Okay, let's see. Let's solve some kind of problems first. Suppose I'm having a graph like this. This is xt curve. This is xt curve and the graph is like this. Okay, the graph is like this. Think about it, everyone. Okay, everyone should think. The graph is like this. Okay. So, okay. So this is 2. So this is 3, 3, 2, 1, 4, 5, 6, right? And this is 1, 2, 3, 4, 5. Okay. 6, 7, 8, 9. Okay. Clear? Now tell me, we have this curve, right? Okay, we have this curve. Now tell me, at time t is equal to 3 seconds, at time t is equal to 3 seconds, this is in second and this is in meter. What is the distance covered? Tell me, at time t is equal to 3 seconds, what is the distance covered? X at t is equal to 3 seconds. Yes, distance covered, right? Distance covered. Okay, think about it. My question is, right? Okay, what's the meaning of this? This means that the person is 3 meters from that point, some point, right? And he's at rest. Okay, Think about it. He is at rest. If he is at rest, then the position is same. Yes or no? The position is same. Think about it. Yes or no? Now, if the position is same, distance covered, because when you talk about distance covered, that is change in x, delta x. Yes or no? Change in x is distance covered. Yes or no? Because this is position time graph. Position is fixed. Is there any change in x? Tell me. Is there any change in x? Tell me. Is there any change in x? Think about it. Position is changing? No. So if position is changing, okay, right? Then the distance covered is 0. Yes, Shash, what is this axis? What is this axis? Tell me, what is this axis? What is this axis? Tell me, what is this axis? And this y-axis represents what? This y-axis represents what? Then that, what is the confusion here? X represents distance, right? Position. X represents position, right? Okay. Now, second question. Find v between t is equal to 3 to 5 seconds. Tell me, what is the answer? Find velocity between v to, tell me, 2 to 5 seconds. Sorry, 3 to 5 seconds. Tell me. Puneet, ulta ho gaya tumhara. V is equal to change in length, delta x, by change in time. Yes or no? So what is change in length? Change in length is, see, initially it is 3, then it is 6. So change in length is 3, which is 6 minus 3, thereby change in time. So it was 5 minus 2. Yes or no? Which is 3 by 5 minus 3, sorry, 5 minus 3. 3 by 2, which is 1.5 meter per second. Clear, everyone? Tell me, clear? Yes, yes, 5 minus 3. Clear, everyone? Well, everyone is clear with this? Okay. Yashas, the answer is in definition, because when you talk about velocity, it is change in position, delta x, by delta t, okay, which is x2 minus x1 by t2 minus t1. This is equal to distance covered. So if someone is asking the distance covered, what is the meaning? Tell me, what is the meaning? If someone is asking you distance covered, it means change in distance. It is change in distance. Initial, right, should be subtract from the final. Got it? I'm talking about question 1 only. I'm talking about question 1 only. Question 1 was, what is the distance covered in 3 seconds? If you are at this point only, right? Suppose this is the initial point, right? And you have moved till this point, right? This, you are starting from this point. This is a reference point. Okay, right? Reference point is, suppose, your home. This is your reference point, and this point is at school. Okay, you are at school. When time started, you are at school only, and you are at school with this. So this is just your reference point now, right? My question was, what is the change? What is the change in distance? What is the distance covered in first 3 seconds? That was my question. Yes or no? Now, if for first 3 seconds, if you're not even moving, if there's no change in position, what would be the distance covered? Tell me. It will be 0 only. Okay, right? So I hope all of you understood this. Now, what is average distance? Tell me, what is average speed? Average speed, tell me, what is average speed? Everyone. From t is equal to 0 to 7 seconds. To 7 seconds. Tell me, what's the average speed from t is equal to 0 to 7 seconds? You can calculate? Yes, very good. Total distance by total time. Hai na? So till 7 seconds, total distance is what? 6. Total distance is 6 till 7 seconds. Total distance is 6. Right? So I can say average speed is equal to total distance, which is 6, by total time, which is 7. 7. So the answer is 6 by 7 meter per second. Clear? 6 by 7 meter per second. Anyone have any issues? Till 7 seconds it is 6 now, right? Okay, clear everyone? Okay, yes, Yashash, what's your doubt? Tell me.
Sir, for question 1, we considered the change in distance, which is because we have already covered a distance of 3 meters, and we did not actually move even a little bit after that. So, sir, here the final distance covered is 6 meters, but the initial is 3 meters. So, we should actually take final position minus initial position here also, which means that we should take the distance covered as 3 meters, right?
Yes, yes. That is what I was hoping. Okay. So here, when you talk about this, right? Initially, it is at 3 only. So total change. Okay, total change is what? 3. Total change is 3 because here the speed was 0. Okay, so it should be, when you talk about this is final minus initial. Okay, because when you talk about total distance, which is final minus initial, always final minus initial, that is the total distance. So it is 3 by 7 meter per second.
Okay, sir.
Now tell me, can this curve represent speed? Tell me, can this curve represent speed? It is negative, right? Means the position is changing, the position is decreasing, right? So obviously when you talk about this curve, this curve, right, is not for, right, this cannot be for speed, right? This is for velocity, or it is speed in opposite direction. Okay, right? So we have to consider that. Okay, that would be for velocity. Okay, because it is changing, it is decreasing. Okay, now I hope all of you got this concept. Tell me, I hope all of you got this concept. Yes, right? Okay. No, acceleration. Again, this is xt curve. This is xt curve. How can you say that xt curve acceleration is there, right? Okay, velocity is changing. That's it, right? Anyways, now is there any other concept in this chapter? Tell me, was there any other concept in this chapter? There's one more concept. After this, we had one more type of motion, which is called as circular motion. Right? Now, what is the meaning of circular motion? Tell me, what is the meaning of circular motion? We know that if a particle is moving in circle, right? If particle is moving in circle, then the motion of this particle is your circular motion. Clear? Right? Clear? Yes or no? Tell me, yes or no? So when you talk about the velocity, so, right, or speed basically, not velocity. Since I'm in habit of speaking velocity, right? I'm speaking velocity, but you should use speed. Okay, right? So when you talk about speed, what is the formula of speed? Tell me, guys, what is the basic general formula of speed? Distance covered by time taken. Yes or no? Time. Now, I want to find what is the speed, okay, when object starts from this point, like, and complete one whole circle. Then I can say the distance covered is 2 pi r, and the time taken is, suppose, capital T. So the speed is given by 2 pi r by t. Clear? Tell me, clear? Right? And time taken to complete one circle. Time taken to complete one circle is called, tell me what it is called? Time period. It is called as time period. Time period. Okay, it is called as time period, right? And we have a term called frequency. Frequency is basically 1 by time period, it is a reciprocal of time period. Okay, right? So this is all we have to study in circular motion. This is our syllabus, that's it. Now tell me, everyone got this concept? Tell me, everyone got this concept? Yes? Revise this chapter? Tell me, everyone. Okay, so I'll upload the exemplar of this chapter. Okay, what doubt you have, Yashash? Message? Tell me, because your voice
So,
breaks. Yeah, tell me.
so when we talk about circular motion, sir, in this case, we can have two different types of motion, sir. One is accelerated motion if we take the motion as linear, but if we take motion as circular motion, we have uniform motion if the object covers equal distances in equal time. So, sir,
No,
if
but actually the point to notice is in circular motion, no matter your speed is constant, we will have acceleration. So the direction of velocity constantly changes.
First of all, right, see, the thing is, you are in class 9th, right? And this is not a foundation class. Okay. Here we talk about speed only. I specifically said speed because when you talk about speed, the direction is irrelevant. When I talk about velocity, the direction matters. At every point, velocity is changing. So I'm talking about speed. Speed is constant, but velocity will change, right? And if velocity will change, there is acceleration. So that we will be talking about in foundation class. Okay, not in this class because it is not in your syllabus, right? Concept of velocity and direction is not in your syllabus now. Got it? So why to get confused, right? Why to confuse people?
sir, so if a question comes in exam whether circular motion is accelerated motion or is it uniform motion, so what should we write for the answer?
See, first of all, circular motion is accelerated motion because there are two types of acceleration. Direction is changing now, right? Okay, as simple as that. And I think you already know this. You guys should know this because we have already covered motion in 2D information class, right? I hope these are things are already cleared now. Yes or no? Right? So here, the motion is accelerated because there is change in direction, right? Okay, so motion is accelerated. Motion is accelerated, right? Acceleration is there due to change in direction, as simple as that. Okay, because when you talk about uniform motion, right? I hope all of you note this. When you talk about uniform motion, right? It is constant speed in same direction. Yes or no? Tell me. Yes or no? Right? Okay. When I wrote the same direction, it usually means it. Okay. right?
Okay,
Okay.
sir.
So I hope all of you got this concept cleared. Okay. So I'll just take the screenshot. 45 students are present. Those who left, I'll mark them absent. Okay, because I don't have time for this. Okay. Anyone have any other doubts? Tell me.
No doubt, sir.
Okay, very good. So next class, I'll upload the exemplar. We will discuss all the other concepts in exemplar and problem. Okay, in theory, right? This was the theory that we have covered. Okay, Prahlad, practice more problems on those, increase, decrease. Okay, clear? So I'll upload exemplar today only within 5 minutes. Please solve the exemplar till next class. Okay, clear? Please solve the exemplar till next class. Okay.
Okay, sir.
Okay, everyone. Bye, everyone. Take care.
Bye,
Bye,
sir.
everyone. Bye, everyone.
Bye, sir. Thank you, sir.